1. Recognition of running gait of track and field athletes based on convolutional neural network. Qiusheng Lin and Jin Wang. Guangzhou Huali College, Guangzhou 5113-5, China. State Grid Shanghai Municipal Electric Power Company, Shanghai 200120, China. To abstract. With the continuous development of competitive sports, higher requirements have been put forward for the athletic level and technical movements of track and field athletes. Running gait is a key factor that affects the competitive level and technical action of athletes. Therefore, the research on the recognition method of running gait of track and field athletes based on convolutional neural network is proposed. According to the internal noise type of running gait image, the least mean square filtering algorithm is selected as the pre-processing method of running gait image, and it is used to remove the noise of running gait image. Based on this, the LBP feature, Hu moment invariant feature and Haar-like feature are extracted as the running gait characteristics, and the convolutional neural network model is designed. With the above designed convolutional neural network model as a tool, the running gait recognition program of track and field athletes is formulated and determine the calculation formula of the relevant parameters. In order to obtain accurate results of track and field athletes' running gait recognition, the experimental data show that the maximum accuracy of running gait recognition of track and field athletes obtained by using the proposed method is 94%, which fully proves that the proposed method has better performance in running gait recognition. Introduction. In the grand occasion of the development of competitive sports, the competitive level and technical movements of track and field athletes around the world are improving and perfecting day by day. At present, it is believed that in order to achieve good sports results, it is necessary to emphasize the economy of running, increase the stride frequency while maintaining a larger stride length, and maintain a stable body weight during running. Therefore, how to improve the scientificity and rationality of athletes. Running gait is the key to enhance athletes' competitive level. The existing methods cannot accurately identify the running gait of athletes due to the backward application means. So the research on the recognition method of running gait of track and field athletes based on convolutional neural network is proposed. For research on the recognition method of running gait of track and field athletes. Running gait image preprocessing. The images of running gait of track and field athletes are obtained through cameras or mobile phones equipped with CMOS devices. Due to the existence of shooting conditions, device defects, recording equipment, image content, and other factors, it is inevitable that the image data implementing the recognition method will have different levels of noise interference. The direct visual effects caused by image noise interference usually include image structure information destruction, boundary pollution, detail loss, image pixel value distribution complexity deepening, etc. These influences will directly cause great trouble to the subsequent running gait feature extraction. increase the complexity of the operation, and then lead to a sharp decline in the recognition accuracy. Choosing an appropriate image preprocessing method for running gait recognition can help improve the data quality, reduce the processing difficulty of subsequent research, and greatly improve the efficiency of running gait recognition. Live running gait feature extraction. Based on the above preprocessed running gait image, the relevant parameters of running gait are defined, and the running gait features are extracted to provide a basis for the subsequent design of convolutional neural network model. In the teaching of track and field sports, the running stage is generally divided into supporting stage and flying stage. The supporting phase includes landing phase, the moment when the swinging leg touches the ground, to landing phase, the moment when the supporting leg leaves the ground. The flying phase includes the phase of the support leg leaving the ground to the phase of landing. The parameters involved in the running gait of track and field athletes are as follows. First, time parameters. The gait cycle is just the time from foot following to heel landing on the same leg. The normal gait cycle can be divided into two phases, the supporting phase and the swinging phase. Support phase, from heel landing to toe off the ground. The contact time between the foot and the support surface accounts for about 60% of the gait cycle. Swing phase, from toe to heel landing. The time of foot leaving the supporting surface accounts for about 40% of the gait cycle. Second, spatial parameters. The stride feature of gait is the space feature of foot landing, including step length, stride width, and stride angle. Step length, linear distance from one foot to the other, 5. Step length is related to height. The higher the height, the greater the step length. Step length, the linear distance between the same leg and the heel again. The stride length of a normal person is twice the stride length, about 100 to 160 cm. Step width, the width between the two foot travel lines. Step angle, the included angle between the line from the middle of the heel to the second toe and the line of travel, generally less than dexterity. Step frequency refers to the number of steps taken per minute when walking. Six, convolutional neural network model design. Based on the above extracted running gait features, a convolutional neural network model is designed to provide a tool support for the subsequent realization of running gait recognition. The design of convolutional neural network model includes two parts: building CNN layer by layer and training CNN network. The construction process of the network is as follows. The first layer is the input of the network. The CNN network can independently learn the characteristics of the two-dimensional image. The original image is a depth image, which can be directly used as the input of the network. The convolution layer is convolved by size filters and offset, and characteristic graphs are obtained. All the downsampling layers are obtained by the following processing in turn: summing for pixels per neighborhood, weighting, convolution kernel element, adding offset, and then generating a feature map approximately 4 times smaller through a sigmoid activation function. According to the identification of running gate requirements, the convolutional neural network model is designed with the number of network layers of 5. The number of filters is 3 and 6, respectively, and the filter size is 5525. Specifically, the construction of each layer of networks is explained, as shown in Fig. 7. Development of running gait recognition procedure for track and field athletes. Using the convolutional neural network model designed above as a tool, the program for recognizing the running gait of track and field athletes is formulated, and the calculation formula of the relevant parameters of the convolutional neural network model is determined, so as to obtain accurate results of recognizing the running gait of track and field athletes. The whole process of running gait recognition is as follows: collect sample images and mark them, input training samples of each type of running gait into CNN to train the model. Adjust the network until convergence, change the output layer into a softmax classifier, input test images, and identify the accuracy of verification results. Gait experiment and result analysis. Selection of experimental objects. In order to verify the application performance of the proposed method, 100 track and field athletes were selected as experimental objects, and images were collected from the continuous monitoring video of track and field athletes during running. The image extraction frame was 10 seconds. A total of 5,000 images were extracted, of which 3,000 images were used as the training set, and 2,000 images were used as the experimental set. Nine. Convolution neural network model training. The proposed method designs a convolutional neural network model, which needs to be trained before the experiment to ensure the accurate operation of the convolutional neural network model, so as to obtain more accurate experimental conclusions. The training process of convolutional neural network includes 4 steps and is divided into 2 stages. Phase I, forward propagation process. 1. Take a sample from the sample set and input it into the network. 2. Calculate the corresponding actual output. In this stage, the input information is transformed layer by layer and transmitted to the output layer. The calculation process performed by the network is actually the point multiplication of the input and the weight matrix of each layer, plus some deviations to get the final output result. Phase II, backpropagation process. 1. Calculate the difference between the actual output and the expected output. 2. The weight matrix is propagated and adjusted in the direction of minimizing the error. 10. Analysis of the experimental results. Based on the above set experimental conditions, and the trained convolutional neural network model. The running gait identification experiment of track and field athletes was conducted. In the running gait recognition accuracy data of track and field athletes are shown in Table 2. Table 2. Data table of track and field athletes, running gait recognition accuracy. As shown in the data in Table 2, compared with the given minimum limit value, the recognition accuracy of running gait of track and field athletes obtained by applying the proposed method is higher, with the maximum value of 94%, which fully proves the feasibility and effectiveness of the proposed method. Conclusion. This study introduced convolutional neural network model and proposed a new research on the recognition method of running gait of track and field athletes. The experimental data shows that the proposed method has greatly improved the recognition accuracy of running gait of track and field athletes, which can provide more effective method support for the measurement and improvement of athletic ability of track and field athletes, and also provide some reference and help for related